All right, over to you,
Okay.
Don.
Okay. So this is a key concept. You're quite correct to stop us for lunch, Chris. There was spading anyway. So this is the next step in asset management, moving from age-based analysis of equipment to moving to condition-based. And this is very common for hydro utilities to move into what's called an asset health index. And what it is a methodology of appraising the health of equipment. And actually, Chris and I have this slide getting redone in typical colors because this is typically done where green is good and yellow is fair and red is very poor, right at the. So it's very important we get our red and green graph. But what it does is it allows you to go by asset class, and that's the way this is shown on this chart, and to look at how many assets in that asset class are good, bad, and other. And really, this is very, very good for management as well as for the people that are in charge of these asset classes, because then they would know where they need to put investments. Because obviously, you should have a documented investment, and that investment could be maintenance restoration, or it could be a capital restoration or replacement. But there should be something in place to move these assets up in condition. And I guess the only reason you wouldn't would be if you had decided that these assets were indeed not going to be replaced or you're taking them out of service. So I'm going to go through some of the methodology on how this works. And you can see how the health index includes the asset age, inspection data, and typically some degradation factors. So this is where people would weight the various measurements in order to determine how the actual asset health index would be calculated for each asset class. So you'll see people, the types that they would have would be like an additive model, well, which is the single asset and most common. And then there's a gateway model where some parameters act as gates. Now, I have seen the gateway model used where people would determine at a certain measurement, it would invoke additional measurements to investigate the problem more fully. And this is very common for where you wouldn't be able to get all the information on an asset without taking it out of service, but you wouldn't want to take it out of service until it had reached, giving you some indication that you're actually going to take it out. So that's where that gateway model would come into place. So models used for evaluation, if you were to look, these are public, the NHA Hydropower Advancement Project. So you could go look up HAP and you can actually find these. And they've been out for a few years. I think I had heard that they were going to be updating them again. And then this one is HydroAmp, which you have to be a member of CIATI to use. Many members of many hydro utilities are also members of CIATI. So this will give you an idea of using a chart how the asset health index is calculated. So you would have a degradation series of degradation factors for an asset. So I'll give you an example of some of those. If you ever look at insulating oil for a transformer, there would be specific measurements of contaminants in that oil. And if you looked at, and so that would, each one of those contaminants would be a degradation factor. And some of those measurements would be worth, they tell you more about the equipment than others. So they would be given a higher weight. You then would have a method of assessing what condition it is based on a letter score. And then you would come up with a condition indicator and then come up with a total. So you would use this for assets where you actually know how it is deteriorating. Another example of an asset like that I would use would be a generator stator. So generator stators, they'd be using things like partial discharge. and Corona, physical inspection, like there'd be a physical inspection of the stator core. And so you would have all of these different aspects of degradation of that asset, and then you'd be able to weight them. Oh, and I see I've got some nice explanations of everything here. Sorry, when I give this only every couple of months, I forget all how good the slides are. So that just basically puts into documents exactly what I was just talking about. And then there's your maximum score. So typically those degradation factor indicators start with, they use a letter or a number. And I've seen companies use either, where they take it from beyond repair all the way up to best condition. And the description outlines the characteristics that correspond to each score level. And typically they would have data from tests and inspections, and they're compared to each other condition criteria. So these rely on assets, again, that have some means of doing testing or inspections on them, and each of those degradation factors for the asset. And I'm not going to test you on any of these formulas, but it's basically, in order to come up with the overall health index, it's basically just using a sum of the weights times the numerical score over the max score times 100. You just you end up with a number out of 100. And beautiful colors again. This is the typical colors that I would see on an asset health index and by asset class. And typically anything 30 to 30 poor and down, you should definitely have, like, there better be a project in place to repair or replace it. 50 to 70, you're definitely going to have some inspection looking at it. And typically at the 85, in the good and very good, those are the ones where you will have maintenance continuing because you want to continue it in that good and very good category, but there wouldn't be any additional investigation or asset management activities on those assets. It's very important to remember that we count on maintaining our condition through the maintenance programs that we have. So you wouldn't be leaving assets alone just because they're in good and very good. You would be continuing with that maintenance that just to keep them in that area. So you can see this is just an example of how the math is carried out with the three different degradation factors. And you can see how the weight is so the rank, and then you're given a weight, the condition score, and turn into a condition indicator numerical score, and multiplied by the to give the total. And that ends up being in a fair. So this is the most complex method of coming up with a condition index. There are some assets where you only have one measurement. So where you would have like a single degradation area. Some assets are even more simple, where of course they just have an age-based deterioration. An example for that for me would be electronic devices. So electronic devices are only replaced on age. So for example, like your exciter AVR, your generator controls, those kind of things. Basically, they're replaced on age 10 to 20 to 25 years. So this will give you the process for how asset condition assessment occurs. So typically in the plant, you're going to have people doing in-field visual inspections or testing, or you would have near real-time asset monitoring. So some systems will actually have asset monitoring in place. Most companies are moving to where that would go into a mobile data acquisition where you're doing your in-field inspections. So that's you'd have a tablet when you're doing your inspections, something like that, where you're recording the data. There's also a lot of companies that still use paper. So there would be paper in field, and then they would be putting it into a system where it can be analyzed. Or of course, for the near real-time asset monitoring, it would go to a data system like Pi. Somehow that has to be brought together into some form of consolidated data storage because until you can get the data together, nobody can actually look at it. All three of those things have to be available together. Somebody will calculate the asset health index, applied with the degradation factors and the condition weightings. Get your health index results. And from that, you end up with something, the effects being used for long-term planning, short-term planning, or maintenance planning. So the asset health index tells you three things, right? It tells you whether I mentioned a few times you're going to need a project, if it needs to be replaced, but you may also uncover additional maintenance tasks. So if you find that an asset is deteriorating too quickly, you may determine that you need to change the maintenance program as well as just having a separate one-time investment. So that is the process as it's typically carried out in a hydro plant. Is there any questions on that? Well, I'm glad you have the camera on, Justin, because at least when you shake your head or something, I go, okay, good enough. I've also added to this document to show who is typically involved in each of these actions. So out in the field, it shows here is maintenance planning, but really the work that's being done is so the in-field inspectors are doing the work, in-field or plant, the plant workers that are actually doing the work. Sometimes they have contract inspectors come in. I've seen that quite typically for generators, for doing big stuff like gate inspections, those kind of things. Quite often contracted out. Whoever's doing the work. The work is defined by planners. If there's sensor installations required, that's typically done by investment planners. So asset management would have said that you need to put in these sensors to give us the data, and then it would have turned into a project. IT, of course, does all the fun stuff of pulling all the information together. The actual assessment is typically done by subject matter experts, or in this case, I actually added AI to this because the world is heading that way. In reality, if you have enough knowledge about an asset, you could have AI make the assessment. I've only seen it in a couple of cases yet, but I do think that's where the world is likely heading. And at the back end, whoever comes up with your short-term and long-term plans, that would be your investment planning group, and then the maintenance planning group. And you may also find out that it's a training problem, and it may also be somebody that really needs to look at the overall program. Is that I've found quite often in the field that you may have the right maintenance tasks, but perhaps you didn't have enough documentation or enough training to ensure it was carried out correctly. And that's when it leads to deterioration. So this is, those responsibilities may vary slightly in your group. A lot of these things that, we were talking about identifying investments, right? So this would head into the asset management group, all of these functions here. And the asset management group would be guiding the fact that all of these other things are occurring. So what's the next spot to? So we talked about age-based, we talk about condition-based. You should also be able to forecast failure. So you will hear people talk about what's called a whole life cost model for an asset. And that would be where you actually use a failure probability curve for an asset class to determine when failures or replacement or refurbishment investments are required. So you'll see a curve that starts out like this, and this is a whole life cost model that we're talking about developing here. So you can see the first part of a curve is your risk and operating cost. Now, that would include, in my mind, the O&M costs as well. So on this type of asset, you can see the curve that I've shown is one that increases with time. So your risk of failure on some assets increases as they get older, and also their O&M costs increase as they get older. So for example, they start to deteriorate and you have to do more intercessions to keep them running. The capital cost of an asset is depreciated over time. So you'll see the capital cost for that asset start out at the initial investment and depreciated over time. The total cost, the life cycle cost, is the sum of both of those. And so you can see that it has a distinct inflection point. That inflection point is the equivalent annual cost, or the minimum of the equivalent annual cost. This is the point where the most ideal replacement would occur. So this is what the basis of a whole life cost model is. And as now, again, using asset criticality, for my biggest, most important assets that have the most risk, I would ideally start to develop these whole life cost models for those asset classes. And I would use this to predict when I should be replacing them most efficiently. So not just using an age, but also using a failure curve so that I can, and looking at the reality of its O&M costs to determine when to best replace it. So you can compare the curve of an existing asset to a new asset. So we already had, so if you look at these curves, and we already had the economic end of life based on the existing asset, you now can compare that to a new asset. And you can also determine then whether it makes sense to when the ideal time is to replace those assets. So I have seen this done now for a lot of people have done them for generator stators, turbines, um, generator breakers. You know, a lot of the bigger assets that they looked at, and there's a lot more work undergoing with a lot of different utilities for developing these whole life cost models. Now, one thing that you noted that when I went through the risk costs is one of the questions you're going to ask me, well, how do I know what the risk costs are for those assets? Well, you would have to use a failure distribution curve. And so typically for a lot of hydro assets, a Weibull curve corresponds to the failure distribution for those assets. And you can then look at the probability that an asset will experience failure within a certain year. And you'll see the alpha and the beta for the Weibull distribution, that these components of the curve have been calculated for different asset types. So the alpha is the shape and the scale is the beta parameter. And you can see how you can manipulate the Weibull curve using different alpha and beta parameters. So depending on how that asset fails, you would adjust the alpha and beta to that type of distribution. And you can see that as you increase the shape, um, it actually flattens out. It has a longer life. And as you increase the shape, sorry, I said the scale, and I should have said the shape. Variations of shape for scale. I think I caught that one too, correct? But so you can actually see how much flatter the curve is. So you can manipulate the alpha and beta parameters to make it match your asset. And what you'll find is that, so I'll speak particularly for hydro, each generator tends to be used a little bit differently per plant. So based upon the operating context of the plant, the plants sometimes will be, it'll be older. If it's being units that are kept in service rather than switched on and off tend to last longer. So you will find that the alpha and beta will have to vary perhaps at a per plant level for each asset class. So there are some industry references for utility data. A couple of them are published in the States. And basically the intent is you come up with your annual risk cost using the risk of failure times the consequence of failure. So we had mentioned that before. So you know your failure modes. You now get your risk of failure using a Weibull curve. And then so you have the risk of failure times the consequence of failure giving your risk costs. So what are the key outputs of that curve? Like what would you use it for? So the number one that I would use it for would be long-term planning. So I've got I started with asset age. I then went to condition based. But for the ones that I are well within their lifetime, so say for example, all those assets that were in good and very good condition, when do I show a replacement in my long-term planning? And so that's what the Weibull curves are for. And so for those big, expensive, really worthwhile assets, I would make sure I had projects in place for what, even 20 and 30 and 40 years down the road for when they need to be replaced. So that's my biggest use is long-term planning. I also could use it for the current state failure probability, so I could make sure I had contingency plans or enough money in my contingency budget for failures. And then for items where I've got lots of them, the number of failures across the population or over a 5, 10 or 10-year period, those would be more applicable. I find that much more applicable to items like transmission, transmission and distribution, where I've got many of the same. So that's what I would use that for. That is my other method I would use for looking for what investments are required. So now the other thing I'd be looking at is now my end of life assets. And for items that are at end of life, I would be looking at what I have to do with them. And this leads to quite often within utilities, you'll see this leads to actually end of life studies. And it leads, the biggest thing it runs into is this during relicensing. And I understand there's like 45% of US utilities or US plants are running into end of life in the very near future. I think I'm right with that number, Chris.
Yeah.
Yeah, it's a huge number, right? That are within the next decade. And so this is a huge concern. So you can imagine now all of this information that I just talked to you, all these different methods of determining what's required. Um, you now have got end of life studies to add to it for looking at opportunities for investment as well. And of course, at the end of it, and this seems quite strange to me, but I mean, I typically would always be looking at replacement in full or part or refurbishment. And of course, you could just look at an increased inspection or monitoring or upgrading. So you see a lot of upgrading studies, especially turbine generators. People will be looking at increasing their generation. But one of the options that is just starting to show up, I've seen, is simply decommissioning. So you'll see some of the plants where it actually is just not effective to invest anymore. And especially with cheaper options, the solar, wind, et cetera, has come in now, has got a lot cheaper. And you'll see a lot of companies now are looking at decommissioning options. So in summary, our actions to address risk are identified by many functions, the results of which are ideal or coordinated by asset management. Maturity assessments are often the initial step in implementing asset management. So that we talked about, that ugly radar curve where you're looking at all the how well you're doing in each area. RCM and the root cause analysis establish the asset definition, the operating context, the failure modes, the failure cause and consequences. And you can use RCM for establishing tasks. Asset criticality, often pursued as the initial task to focus asset management efforts. And then we talked about asset age, asset health indices, and whole life cost models to identify replacement and refurbishment investments. So those are the big processes that are typically in place to establish those opportunities for investment. And that was the core of that whole area for planning. Sorry, I'm just looking at my where I'm supposed to be at this point? Good.
Yeah, so getting into SAMPs,
40.
AMPs. Yeah.
Yeah, good. So I've got 20 minutes to go into the SAMP and AMP. Great. Okay. So we talked about this box first, the actions to address risks and opportunities. Now we'll be talking about the SAMP and the AMP. So the SAMP. So the SAMP is the overall strategic plan for asset management. It should be aligned with its organizational, financial, and other resource plans. Really, I call it's like the business plan for the asset management group. It should include the asset management objectives and the approach to achieve them, the process to identify capabilities to achieve the asset management objectives, the timeframes, and the approaches to improve the asset management system, asset management, and the assets. So this is important in that it's not just the asset, it's just not objectives for the assets. It's also objectives to improve the system and to improve asset management. So you can imagine now, like we just talked about doing that maturity assessment. The maturity assessment would tell you what you'd have to do to improve asset management. If you're looking at the asset management system, we talked about that. That's a whole bunch of other processes as well. So you'd be looking at anything where your processes need to be improved. And then finally, you'd get all of your investments to do with the assets. So you get those objectives. One of your first steps is looking at the organizational business plan. So Chris had mentioned, say you're adding a new plant. Well, what's the first thing you're going to have to do with a new plant is you're going to have to make sure that you have all those assets added to your asset inventory. You're going to have to make sure that there's maintenance plans. You're going to have to establish the asset condition. You get a whole bunch of work when you add a new plant. So if you look at your corporate strategic plan, the one for the utility, it will tell you of upcoming objectives for asset management. You may also run into something that, for example, the company wants to reduce costs by 13%. Well, who's going to be asked to reduce the costs? It's going to be asset management because anything to do with your asset investments, you should be providing input to say, well, what's my least impact to the company when I have to reduce those costs? Of You'd also be looking at the current internal and external context. So again, has your world changed? So, for example, a big thing in every country is political changes. You'd be looking at any new rules and laws, any, are you subject to flooding? Imagine all the investments that came out of the wildfires that were prevalent in many states over the last few years. That all of those things identified investments that had to be made, and asset management should be part of that decision. We talked about identifying risks and opportunities. That was the whole area we talked about before lunch. And then we'd be looking at the condition, performance, and capabilities of its assets. So, absolutely part of the SAMP should be, based on what you found in investigating the assets. It's revised, on a regular basis based on internal reviews of these sources. And this is one thing I'm going to tell you right now, and we have an example to look at in a few minutes. I've never seen a perfect SAMP, and people will tell you they've never made a perfect SAMP. It's always based on, how good your asset management understanding is at the time, how much work you put into it. People make a SAMP, and it becomes the foundation for their next SAMP, which is better. So it'll be interesting when we look at the SAMP example in a few minutes. You'll be able to tell right away that, there's a whole bunch of stuff in it. It's not perfect and it never will be, but it was the foundation. All these people put time into it and they thought about it. And by creating the SAMP, it helps them understand asset management better and how to move forward. So I always thought of it as just more of a starting point for the next SAMP. So the next level below the SAMP is the asset management plans. So you can see now the flow. You've got your strategic asset management plan at the top. And then you've got amps for all of your different asset classes, or even for specific assets. These again are grouped by company. They group them differently. I've seen them at a plant level. I've seen them for each asset class. So, for example, governors. Uh, there could be, they could have done it at governors, exciters, generators, each of the specific asset classes, depending, say if they had subject matter experts for each of those. But the AMP is the document that establishes how the AM objectives will be achieved for that asset or asset class. It's some people also create them at the station level, and they also sometimes create them at an objective level. The AMPs are consolidated for executive approval of funding. They are the source of the CapEx and OpEx budgets. So you see, I have this in red. This is my, there should only be one AMP discussion. You can imagine now. So say you have your governor expert go through and look at all the governors. You have your exciter expert look at all the exciters. You have your generator expert look at all the generators. Every one of those, they'll be used, in theory, should be using the consistent evaluation criteria from that decision framework to determine what investments they're saying for that asset class. But somebody's got to pull them all together. So they took a look at all of these amps and they pull it together into your capital plan and your OpEx plan, right? Because all of this work has to come together for executive approval. Asset management doesn't provide funding, the executive does. So asset management proposes a plan based on all these proposed investments, and then the executive signs off on them, saying you can have this much money for capital, you can have this much money for OpEx. So the intent is you would pull all of these various amps, each one together, make it into your overall one investment plan, one for OpEx and one for CapEx. And that's the way, and then those are the ones that go to the executive for approval. So that's the way the process is intended to work. You would never, and it's got to be all brought together because you wouldn't put forward just your generator stuff and your governor stuff and your exciter stuff individually, because then you'd lose that coordination function. Because maybe it's better to put more money into your generators than it is into your governors, right? Or maybe some of your dam safety tasks investments are more important than your governor tasks. So you've got to put it all together into one plan and weigh your investments. And that's where that coordination function for asset management comes in. So what's in an AMP? What should you see at an AMP level? I would want to see all my asset demographics. So I'd want to see, if it's on governors, I want to see my list of all the governors. I want to see how old they are, what condition they are, and what are the risks from the governors. What levels of service are we looking to see achieved? Typical failure modes, the asset intervention strategies, maintenance planning, capital replacement and refurbishment planning, life cycle analysis. So that's the stuff from the whole life cost models, and your data and monitoring requirements. So these are really detailed plans too. Typically, I've seen them 40 pages long for an asset class. If they're a station, maybe 100 pages. So these are detailed. And obviously, these are the kind of things you would only change these now based on your review periods. And in order to keep these practical, you would only want to create these detailed plans for your critical assets. And you would, for the less critical assets, you would basically just have, a much smaller document that just said, these are the tasks that we're going to do. And may in fact just have reactive replacement projects. So does everybody understand the difference between the SAMP and the AMP? Okay. And this just shows how it goes together. This is it's funny. I've looked at this slide a few times to see which one I would draw first. And I your analysis based on condition in my head would give you your short-term plans. So you've looked at asset condition, in detail. You've said, okay, now I need to replace this unit in 5 years. I need to do this one in three, and you've also done your failure mode analysis where you've come up with your maintenance plans. So that gives you your OpEx budget, and then based on that, because those decisions dictate. Remember when we did the whole life cost model, we had the risk costs and the O&M costs that dictates your long-term plan. So now you made your whole life cost models, where you come up with your 20 to 50-year investment projects. And those in turn feed back to your short-term planning and maintenance planning. So it's much of a circle, and you could almost draw these things with this first two on the left and this one on the right. Doesn't matter because it all feeds into each other, and that's what the important part of this slide is. It just because whatever you decide to do for maintenance, whatever you decide to do for your short-term projects dictates what you're going to have to do for your long-term projects and vice versa. The intent at the end is that, and this is, remember, we talked at the beginning, what is one of the objectives of asset management is to have levelized capital investment. And so with this analysis that we've been doing, because now you've planned your long-term stuff, you're looking at all of your making sure you're doing your maintenance and all this good stuff. In theory, you should be able to keep your investment levelized. And the whole intent is that then you could come up with a target that meets your risk requirements, and your management understands those risks, and they get to be able to see a level target. So none of this reactive stuff. One of the other important parts of this chart that you'll see is the backlog. So again, we talked about those aging assets. There's a huge backlog because people weren't doing asset management historically. So by managing your risk, you handle your planned replacements with the backlog to slowly eliminate the backlog over time. And then in theory, you should get to the point where you don't have a backlog. But obviously, like every company is at the point, you can't eliminate that whole backlog at once. There's just not, there isn't the budget for it. The summary, the SAMP identifies asset management objectives and high-level strategies to improve them or to achieve them. The AMPs are the detailed documents. We talk about that's right down at the assets and the asset details. And the outputs of the opportunities identified in the SAMP and the investments from the AMPs are consolidated and form the foundation for the OPEX and CAPEX budgets, which receive funding approval. Good. So, exercise. Are we on time for this, Chris? 12:53?
Roughly, yeah.
1:53. Good. Yeah, we're actually 7 minutes ahead. Can't believe it. Okay. So this is a test for everybody. So I managed to find the biggest, ugliest SAMP in the world for you to look at. And it is, I can show it here. I'm just going to show for a second. So is everybody able to open this? This is the SAMP for the Federal Columbia River Power System. And what I'd like you to do, if you wouldn't mind.
So is this in our pathways or whatever, our documentation, or is this something we need to download? And if it's a download, can you put it in chat?
So it's in the LMS.
Okay, thanks.
Yeah.
Okay. I could copy this and put it in the chat if you want.
It's part of the course materials.
Okay.
Yeah.
Let's see if that works. So what I'd like to do today, could you spend 5 minutes Now you'll notice it is 133 pages long. You're not going to be tested on 133 pages. The intent is Don just talked for 3 hours or two. Take a look at it at a high level. Don't get mired in the details, and just take a look at what this group of people did for this big organization, and then we'll have a discussion on it. So take about 5 minutes, and then we'll have 15 minutes discussion for a few questions. Get the timer going, Chris?
Yeah, so it's 1:56, let's say.
2 o'clock, a couple minutes after.
Yeah.
Okay. Okay, cool. So some of the things I'll give you to look for as you're going through. Alignment with the different plans. So asset management objectives, the process to identify capabilities, timeframes, and then approaches to improve the AM system, AM, and assets. So just look at a high level. Did you read the plan, Chris?
I skimmed the plan.
Exactly the right level. I can't believe how much work they put into this thing, actually.
There's quite a few stakeholders to manage.
I can just imagine what it was like
And-
to get them all together.
And customers and et cetera, et cetera. So yeah.
Oh, yeah. They should have had a measure at the end of it, how many meetings it took to put it together.
All right, John, we're, I think, about at
Yep.
time.
It's good. Let me just find my slides. There we go. Good. Okay. So the first question, and this exercise relies on everybody being awake enough and contributing. So we'll see how well we do. Did this example?
We supposed to see your screen?
Oh, that would be me not sharing. I mean, like that.
All good, all good. I wasn't sure. Maybe it was
No, thanks. I always forget when I turn it off. I went back and fixed my 55,000 in the first slide. Good. So first question is, did this example clearly demonstrate alignment with organizational, financial, and other resource plans and other AM documents?
still can't see.
Really?
Yeah.
Huh. Yell at me. Let's try that.
Nice. Okay. Now we can see.
Thank you.
Yeah.
Takes a lot of training for these instructors, you know. So what does everybody think? Got to hear at least one answer before we go back. And if I don't hear any other answers, I pick on Justin because his camera's on. So is anybody going to save Justin?
I think it said it in
Yeah.
many different words, but I didn't find a super clear initial alignment. I mean, I see their SAMP strategic plan overlap, which was kind of, I was looking for pictures.
Ah, yeah. Especially when you're doing the five-minute skim, right?
Yeah, I think they did a decent job.
Yeah, this is a huge organization, right? Like Chris and I were joking about it while you were reading, but this is now it's BPA and the core. You know, it like I wouldn't have doubt if they had 100 people contributing to this document. I don't think it'd be any less. So, anybody else with a comment? Just Yep. Well, I'll tell you a couple of things that I saw. So I did see alignment with the organizational strategic plan. So not in a pretty picture, though, Justin. I agree with you. I saw the relationship with the other SAMPs. So they mentioned how there was a SAMP for this area, for the Columbia River. When I went online as well, they also published about 8 other additional SAMPs for the areas they carried out. So some of the things I saw in here that I have seen in separate documents, but they included in the SAMP. So the asset management commitment and senior ownership. So did you notice that, like in there, I'd mentioned that you've got to have an asset management policy and you should show leadership commitment. There is actually a documented section on the leadership commitment and it's signed off. Roles and responsibilities are clearly identified. So they've got a whole section on the roles and responsibilities. Again, I would, typically I've seen those external, but they've rolled it all into the SAM. They showed the scope of the asset management system. So they talked about the asset portfolio. Stakeholders and expectations. So we talked about that. And so there's a whole list of all the different stakeholders and all the different expectations for those stakeholders. So which helps to identify their risks. There's a whole section on the operating context, which is awesome. So now it defines how all of those assets are meant to be operated. It goes through and develops their decision-making methodology. So you know how I showed those different value framework categories and all the different impacts? They went through all of the different areas of their decision-making methodology. And they also talked about their criticality model. So to me, as a SAMP from an alignment perspective, I thought this was a pretty good document. And again, this is why I mentioned right at the beginning, are these things ever perfect? The answer would be no. But for somebody like, for a group like this, they probably don't have a place to put some of these extra documents, so they put them all in the SAMP. And I think, that way it's all in one place. So any other comments based on, what we just talked about then?
Just that reclamation is in here as well, Don.
Yeah.
Yeah.
Yeah, like all the three. It's huge, isn't it? Like you know the groups better than I do, but I just think of trying to get all those people together and put together this document. It just seems unfathomable.
Yeah, and I think there's several folks from the Northwest on the call, but in principle, Bonneville is the administrator slash asset manager, so to speak, for core and reclamation assets, that make up the FCRPS. So they don't own the assets, but like I said, I believe they administrate and kind of serve as asset manager on behalf of core and reclamation for that area. And then over and above, you've got LDCs, local distribution companies, buying power from said assets. So you've got the PUDs and et cetera, et cetera. So lots to manage internally with the core and reclamation and externally with those customers. So
Yeah, interesting, right?
Yeah.
You can see why it ended up at 133 pages.
Yes. Yeah.
I have seen these SAMPs for smaller organizations done on a PowerPoint with 6 slides. So yeah, a little bit of range. This one is an example of everything I talked about this morning. I mean, this example's got everything. Let's talk about point 2. So did this example clearly document the objectives and risk to implementation? So were you able to see how they developed all these different objectives, all these different investments that they should be doing, and the risk to their implementation?
Indirectly.
So somebody's got to save Justin this time. Anybody have an answer for this one? So when I went through the document, I saw that it has an identified future state. And I saw that it does identify the investments and the spend levels. So it talked about the investment for the different targets. It had a 10-year capital program, and it had a 10-year expense program that were included in here. And it also had a separate section, which I was quite pleased to see, on the implementation risks by value category, and it addressed the barriers. So again, for such a big organization, and for the number of assets that it has to cover, and you can imagine the struggle of how much information to put in here and how much not to. I thought it did a pretty good job of pulling that in. I would think over time, as they developed more detailed asset management plans, so if they move some of the detail out to those amps and then pulled the SAMP back to more of a summary, I think it would be clearer. But does anybody have anything to add to that? This is a publicly identifiable or a publicly available document. So you can use this as an example. You can take it away. You can learn from it. I thought it was, I was really surprised to find it because I had been doing some searching before to provide an example with this class. And you can take it now, compare it to the ideal stuff that I've been teaching. And you can see where, perhaps things you would improve, things that, but it shows you that all of the things that I've been talking about all morning is in practice. So people are doing this work. And give you an example is to take away and decide, how these things affect your job. So with that, Chris, and everybody here, I think that ends our review of this document. Oh, I had one more. Sorry, I had one more question. Justus and Ricks. What strategies did the SAMP demonstrate to identify risks and opportunities? So this goes back to our planning discussion that we just had before here. So which ones did you see in there for using risks and opportunities?
So there's a risk assessment section. Would that qualify?
Well, it is for parts.
And then there's a
So what
future
I saw,
state. Yeah, go ahead.
So the ones that I saw that they use, so one that we didn't talk about, which is often done, so the SWOT. So that's a strengths and weaknesses, opportunities, threats analysis. So that's typically done when you're looking at doing your macro environmental analysis, right? From my MBA, I think I remember that's where it comes from. They did an AM maturity assessment. So you'll saw that. Matter of fact, I stole the one picture from there. So by area of the asset management, they looked at their maturity and identified opportunities there. They did an O&M analysis, so containing the current strategies, and they said it would be improved in the future. They looked at asset criticality, so asset criticality was in there. Cost analysis was in there, so you saw that they did their O&M and per megawatt hour. They looked at asset condition. They did asset performance, financial availability, and cost of power. And they also did a risk assessment. So the one that you picked up, Chris. So you can see these are the tools that I talked about in the training, and this is the tools that they've applied within their company. So very applicable, and you can see, like, I know when you go through in detail, you'll find that some things could be better, some more detailed, but very impressive effort for all those assets for sure. Okay, right, everybody. So that does conclude our look at this item. And that brings us to a knowledge check. So what document is designed to convert organizational objectives into AM objectives while also providing direction on how the organization can achieve those AM objectives? And we may have just spent 20 minutes looking at it. Melissa guessed perfectly right again. So C, it is the strategic asset management plan. Okay, one more. So what types of analysis are often performed to identify asset investment opportunities? So the FMECA or RCM, age-based analysis, condition analysis, whole life cost model analysis, or all of the above. Let's see if Melissa wins being the first person to answer. Oh, you were first again, Melissa. Well done. It is all of the above. And you'll notice all of those were also in that example. In our example from the Columbia River. Great. So we're now on to support. So how are we doing on time, Chris?
I think you're 10 minutes, running 10 minutes early, which is fine.
Perfect. I heard somewhere I'm supposed to get 15 minutes. So good. All right. I think we're ready to go. So now talking about support. So we talked about all the planning stuff, and now we're moving into, well, what is required to make asset management function, all the support functions. So I've grouped a few of these together. And so first one is resources, competence, awareness, and communication. And the reason why I grouped them together is I have found that these areas are covered under the title of organizational change management. So if anybody's taken ProSci training, those kind of things, it's basically, this is the people side of asset management that's often overlooked. And it is really one of the first cornerstones of asset management. If you don't have people, asset management doesn't work. We talked about the team organizations before. I have seen a lot of the asset management groups now have started to include communication and organizational change management positions in the AM organization, recognizing the fact that you're changing all of these processes and changing the roles and responsibilities, all of this good stuff, really affecting people's jobs. So for asset management to be effective, you've actually got to consider the organizational change management principles. They often initiate it, so they would start asset management with training of the executive, AM practitioners, and all of the involved groups at different levels. So usually it's like a 1-day course for the executive, and then a week for AM practitioners, so for having people certified in asset management. And then there would be some form of knowledge transfer, so sort of letting people understand what asset management is and how it affects them and the organization. A half day, longest, to maybe even just a couple hours for all involved groups. So typically there's quite an amount of training that occurs with asset management as it's implemented. And typically the group that would do your maturity assessments would be the group that, you'd probably stay with the same consultant, and they would do your asset management training. So some of the strategies to improve asset management adoption within companies that I've seen. One of the first ones we talked about, and it was in that example we just looked at, was the clearly identified demonstrative sponsorship. So you've got your EM policy, you've got documented roles and responsibilities, and you've got that leader in front for making sure that people know about the necessary changes. Using standards. So you can imagine, like, if I were to sit and even just to do this training class, how would I train you on asset management if I didn't have a standard to look at? Right? What would you use as a reference? What if people wanted to dig in deeper? You've got to have a standard in place to provide direction for people. So having those standards used for your work, whichever one you pick, that will allow people to more easily understand what's required for asset management. Another big one is a consolidated data set to ensure everyone across the organization uses one source of truth. So this one actually ends up being a bit of a hang up for a lot of companies. They start putting asset management in place, and then they find out all of the data that they need for asset management activities isn't in one place. You know, and I've seen, like, my company, when I first started, we had 6 CMMSs, you know, and so that was 6 lists of assets, some of them with duplicate assets. So how did you ever make those things, you know, talk together? How did you make any asset management decisions? So that was really important. And you'll see it actually takes a couple of years for most companies as they move into asset management. Having the policy, the SAMP and AMPs to guide asset management and ensure clear ownership, and looking at that alignment with the corporate goals. So if you've got your corporate business plan and you show the alignment of the associated documents, it always helps people understand, well, where did all these tasks come from? The next one is the asset management maturity assessments. So what I found with those is they help people understand asset management. So my first learning with asset management was actually doing a maturity assessment. And, you know, by the time you walk through the company and you did an assessment, either with a consultant or tried to do it yourself, it increased the knowledge within the company of how asset management was supposed to work and what was in it. So it helps you identify gaps and establish ownership for change management. So it really helped move the asset management forward in the company. And then the next big thing is the consistent use of a risk-based decision framework. So building that decision framework was the first transition of the company to actually starting to think about risk. Because people, you know, like I'm an engineer by background, and I mean, I was trained to address risk, you know, and of course to make sure that failures didn't occur, and you know, not to, that you wouldn't impact people or equipment, right? But my methodology for assessing that risk would be different than every other person that was in the company. The decision, well, by the time you got people together to come up with this decision framework, it now got people onto the same, you know, they were all thinking the same way. So that what I thought was an important failure was the same as what you would think was an important failure. And just those discussions in developing the framework was really important for that change management aspect. The next thing I've seen that really helps is the reinforcement through measurement. So, you know, everybody knows the what gets measured gets managed kind of criteria. So when you start to develop these measurements and start to deploy them within the company, now all of a sudden you've got people seeing measures up front that in align with your asset management plans and help you move the organization forward. So, you know, it's very important that you have the executive dashboards and KPI reports, that you have auditing in place to ensure the accurate decision making and data. So this is very important to make sure that data is correct. And also that you've got you now are looking at any of the variances that cause cost variances and help the utility develop justification to support the variance. So it's really important. So as you get those processes in place, and I'll pick on a few. So for example, your maintenance program, you know, you said you were going to spend this much on maintenance. Did you actually carry out this maintenance? What were the actual costs? Were there any other failures? Now moving to capital, how many companies actually look at your capital variance from original estimate? Or did you achieve the objectives from your capital investment that you were supposed to? So all of these things, bringing them up full in front towards your management, that helps move asset management forward. And you'll find that you can only develop these things area by area because it's just so much work to get the measurements in place. So the next area to look at is documentation and knowledge. So this is one of the things you'll find, especially for an ISO standard. If you don't have a documented process, it's like saying that you don't have that process in place. And my experience has been, with various management measurement systems, is that until you get to a point where you have a documented process, the best performance you will get is individual best performers. So you will get individuals that do very well, but you will never get the overall system to move beyond a certain level, because you'll have some people that are not doing very well, and then you have those best performers, and it averages out at a lower level than if you take that knowledge from the best performers and bring it to everybody. So all ISO standards require that you have documented processes and that they're measurable, and that allows that improvement. The other thing that of course enables is role-based training. So until you have that documentation in place, you can't provide the training. So roles and responsibilities and then documented processes enable the training. And now, of course, now you've got documentation in place, now you need to have a management of change process. And this is now for your process improvements. There's also management of change for knowledge changes too, like for asset information, all of that good stuff. So we talked about organizational change management in one of the previous slides. This is now management of change on your asset information, processes, all of that good stuff. You need to have management of change processes in place as well. And then the final part of this of documentation and knowledge, and this is just came up with the newest version of the standards. Sorry, I'm just gonna a little dry here. In asset management, they finally recognized the fact that you have to have a means of capturing your organizational knowledge about your assets. So I'll give you one simple example, your operating context for an asset. Where do you go find that? I'm thinking probably in most of your organizations, you wouldn't know where to find that. The whole intent is have a consistent place to put it, document it, and then it's stored and people can reference it. How things work. So where do you find all of your drawings? So how do you find all your operating procedures, your maintenance procedures? How do you know how decisions were made, how procedures were executed, what to look for in an asset condition assessment? All of this stuff from your experts. Where do you keep that information so your organization has continuity and can grow? So this is now an explicit requirement of the ISO standard to actually look at knowledge management. And there should be some way of tying that knowledge back to the assets so that you can look at it and refer to it. So very important. I really like it because now it talks about, making sure we don't lose that expert knowledge over time. So let's bring me to the next one. So data. So where people was the first cornerstone of asset management, data is the second. And this is the one where I've got a lot of experience where organizations have trouble moving forward with asset management because they get hung up in the data side. They, they first start and they go, wow, this is great. I get, my policy done and, initial SAMP. And the first SAMP says, well, I have to go find all my assets. And then they go looking into their asset systems and they find out that they have asset information all over the place. It's not consistent. It's not consistent plant to plant. You can't do any sort of analysis on things. And then the very first thing that leads to is now you've got a cleanup project in your asset management systems. And And they try and get so much of that going at once that asset management falters. You end up in like a CMMS project or something like that when you should be working on your assets. So really, really important. I talked about for change management, you got to have data to make all of these in asset investment decisions. You need data. So it's really important to get this data together, but you have to really focus on what information I need in order to move forward. Now, and what you may find, and I'm sure you're going to in your system, is you've got data all over the place. So you've got plant information, you've got your equipment specs, you've got calculated data fields, you got artificial data fields, you got periodic inspection data, your predictive and maintenance inspections, work order data, condition and risk assessments. You got stuff all over the place, and some of it's integrated, some of it's not. So it's really, you have to really make sure that you don't get too hung up in all of this with everything. And that's why, in my mind, there's a minimum data to get started. And oops, I've killed excuse me just a second. There we go. Oh, good.
Okay.
Yeah, I'm fixed. Sorry, I had the schedule up instead of the my speaker's notes. So some of the examples, of the data that you would have to look at, and this is one of the things that I found, is that a lot of people have invested from a capital perspective to put in monitoring systems. So this would be a typical monitoring system for your hydro assets. You'd be able to see each unit, and you'd have all your voltage, et cetera, and the speed, and all of everything to do with that unit. All of this information is being captured into some sort of a data storage system like Pi. You've got all this data, but nobody ever set up processes from an asset management perspective to take a look at that data and make investment decisions. They did have processes in place that if a failure occurred, they would use the data to analyze the failure, but nobody was using it for tracking and trending to determine, asset health indexes, you know, or um, or following through to determine if there was additional maintenance tasks required. They were typically at first put in place for operating the unit and for doing reactive um, root cause analysis. The other thing that you would run into is data quality. So again, because nobody was doing analysis on this data, you would run into a data quality problem. And everything, from your real-time systems, typically you would know if an input was out of calibration. There would be tasks to make sure the calibration of all of the input systems was done on a reasonable basis. Now, manual entered data, typically nobody ever looked at. So for example, the inputs that are going to go to for your maintenance inspections, for your runouts, for your temperatures, all of those things, there was typically there was no processes in place to make sure people were putting in the right data. And so what you run into is problems with, now that you start to put asset management in place, data quality becomes important because now you're looking at that stuff. And it ends up being, you end up with a lot of retraining. You end up with putting in processes that capture misinformation entry, and quite involved in order to ensure that data quality. Also, I mentioned earlier about the management of change. So keeping up with asset data and the changes in asset data, also very important. So again, processes to ensure that, if a transformer is replaced or a breaker is replaced, that new asset data gets put in. and the appropriate maintenance tasks are put in, et cetera, et cetera. So really, really important to manage that asset data quality. And just to give you an idea of some of the systems that you'll run into, in asset management. So I've said a few times the CMMS. For those of you that aren't familiar with it, the enterprise system of CMMS is a computerized maintenance management system. A lot of those you'll see that would be Maximo or SAP, SCADA, system control and data acquisition. So that would be used for typically at a system level for control. GIS for a geographical information system, the ERP for enterprise resource planning. That typically ends up being the finance and people side. So again, SAP and Oracle, probably the big ones. Got all kinds of electronic data files, all kinds of paper records, and then information that's kept by subject matter experts. So all of these are required to be pulled together for asset management. So you can imagine now why quite often the implementation of asset management turns out to be an IT project to put all this stuff together. And you also can imagine like these four big boxes over here. How do you make sure that the generator one in one of your plants in the SCADA system is the same as generator one in the CMMS? How do you get data together? And from a cost perspective, does your work orders that are in the CMMS, how do you make sure that they roll up to the right areas in your ERP system on where finance is performed, where you're doing your financial analysis? And then the GIS is in some ways a duplicate of the CMMS. It's just looking at those assets geographically rather than hierarchically. So how do you make sure all those things, how keep them all the same? So quite an effort from the asset management team. So you can see now why you definitely need those standards required. Oh, I see. I put another one on this slide, but it wasn't in the other one. The operational system. So um, and that would be like your plant operating systems, SCADA, your ERP, your work management system, or the CMMS. You've got long-term planning in your financial systems, um, asset and investment planning, AIP, for your short-term projects, APM for this is asset performance management. So you get hung up in acronyms too for maintenance planning. And you've got your work in the CMMS. All of these systems have to work together and they all have to be integrated. All of the, if you have an asset, you've got to have that single asset identifier so that you can identify it from system to system. And so you can look at all of this information. I'll give you another example of where this integration is required. Imagine you come up with a capital project. So your capital project is to replace an asset. Well, you better know that asset in your EIP system is the same asset that's in your CMMS system. Because if you don't know what assets your project is on, how do you match how do you look at your life cycle costing? So all of these things become very difficult to integrate in, and you end up having to go in by your critical assets, making sure your critical stuff can be found throughout all of these systems, and so you can manage the costs and be able to do your analysis. So in summary, this is all about support, and the first thing we talked about was the people side. So the people side were the resources, the competence, awareness, and communication. And that's best addressed by following the principles of organizational change management. So go out and get your pro side training, and that helps you handle all of this part from the people side. Documentation and knowledge management ensure repeatability and quality of actions and decisions. So that and then the data, that second cornerstone, enables the AM decision making. So we talked about all of those systems that your asset management data is in and how you have to make sure that it's consistent and can be tied back to your assets. And there's many asset management supporting systems. and asset management has to provide the standards to enable analysis of data. So the next one, so I have a knowledge check for you, and I didn't talk about this in too much detail, so I'm going to talk about it as I go through it in here. I probably scared you all with talking about how much information you had to get together for asset management. You know, you got to have all this stuff together, all your project, all. But to get things moving, what do you really need to know? Well, you need to know your equipment description. What is it? So there's got to be some standardization there, right? You have to know where it is. So it's location. So whether that's a functional location within the CMMS or a physical location, it's GIS side, it has to have a unique identifier. So that unique identifier has to follow it through from system to system. You need to know its installation date because your very first analysis is going to be your age analysis, right? So you're going to have to know when did you put it in. And you have to know its criticality because now that's the first thing you need to do to move forward. Everything else, and now as you get to D, you're starting to get, you can imagine there's all this other information that you have to know, is to move forward in more extended analysis, like your reliability data, your condition and risk assessments, your whole life cost model, all that good stuff. That all builds upon C. So if you have this base information in C, then you can move forward with your asset management program. I did have an argument with, not a discussion with somebody when I was going through this. Somebody argued, I guess if you knew this, this is your start. At least you've got so at B, you've got your portfolio. But in my opinion, you need to at least know what happens when the equipment fails. So you have to know what that equipment, what the consequences of failure are. So my argument is C. If anybody's taking the test in here, and you all will be, C is the correct answer. Good. So that brings us to operation. How are we doing on time, Chris?
Sorry, I was on mute. I think we're 18 minutes early.
Okay, perfect.
So, yeah, let's dig in a little bit and then maybe we'll go to break 5 minutes early, something like that.
Okay, all right. So operations. So this is where we talk about the how the asset management aspects of how you're actually running your assets and control of change, and then your external process products and services. And no, well, I'm sorry, I'm not going to get ahead of myself. Okay. So who here is familiar with what an asset lifecycle is? And this is really important because asset management isn't just about the operation phase. And it's not just about maintenance and decommissioning and planning. It's about all of these parts intertwined. That's that coordination part of asset management. So it's managing an asset throughout its life cycle to obtain the designed value. And so when Chris talked about you buy a new plant, that's now in the planning and acquisition side. And then once it's put into service, it's the operation, you're doing maintenance on it. The end of its life cycle, it's decommissioned. And you should be looking at all of the investments required throughout that life cycle. You may find that some of those groups are not distinctly within asset management for sure. So for example, like that business acquisition function, you're not going to find that people studying business acquisitions are going to be part of asset management. But there should at the very least be a coordination by the asset management group to ensure that the identified investments are carried out as planned and to identify opportunities for improvement. So there should be a tie back, that consultation. And then, you know, as an example for me, um, when they're building new plants, as an example, you should know what the new plant is going into place, you know, as part of when when it's being designed and goes into the acquisition phase. At that point, you should, as the contracts are confirmed, you should know what assets are going into service. You can then at that point you can start to decide, you know, what the maintenance and operation requirements are for those assets. And so as soon as it's put into operation, you can put in that O&M work. And you should already know then approximately at what age you're going to need replacements for those assets. So you also can put the replacements in for 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 um, for the new assets. So those in the long-term plan. And I'll give you some of those actually kind of sneak up on you. For example, um, the buildings used for maintaining or the crane. Let's pick on the crane. The crane during construction gets some of its heaviest use. So actually, the crane is up for a major service almost immediately upon plant of in service day. The all of the heaters, the H&B systems, all of the stuff used for your accommodations for building the plant, those accommodations buildings typically get put into use as the maintenance buildings after. Those buildings are all of that stuff is 10 years old by the time the plant gets put in place. So you've got to really be thinking, you know, as this plant is being put in, you've got to be thinking about the whole life cycle, and you've got to make sure you catch it early enough so you don't get these early failures based on, you know, you really wouldn't expect with a new plant. So each phase of the asset life cycle requires documented, measurable processes. It's a very significant investment, but also has significant returns. Now, um, I've actually seen measurements done for the oil and gas industry. I've never seen it for hydro, where they talked about like almost a ninefold uh, return on the investment of setting up these systems during the construction phase versus waiting till after the asset was put in service. So very important to capture your asset during the planning and acquisition, because it's a lot easier to capture all that information right at the beginning rather than waiting until you get it in the operation phase. So big return. And so, you know, you can imagine, like, you know, some of my negatives here. You know, if every group has separate capital plans and supporting systems, they have separate procurement processes, separate operating plans and processes, separate, you know, and you can see I've got and in brackets because you can imagine every one of these has a separate system. So it just doesn't make sense to have all of these different groups having their separate systems and separate processes. Way too much overhead. Management of change. So we talked about this a little bit before because it was part of the data requirement for ISO. This is now for the management of change of data during operations. So processes must be in place to document and respond to change. Ideally, asset data will change in parallel with the asset replacement or exchange. So, you know, small stuff in the plant, you know, say somebody changes out a generator breaker or a pump, you rely on the plant people to keep up with that. But they have to change that data out in a timely fashion, and they have to show that the old asset was taken out of service, so there's codes for that, and they have to show that the new asset was put into service. You also run into places like quite often within a plant, you'll run into assets that are switched out for maintenance. So again, a big one for me for that would be generator breakers. Sometimes they'll take the old one out, put it, you know, they just swap in one that's on a cart. pumps, especially pumps, used for like dewatering the unit. So like dewatering pumps, they may actually be used in all different places. Um, any things like mobile equipment, all of these things, you have to keep track of them and where they're used and where they're found. And it's really important that the asset data follow the asset in these systems. So if you don't do this properly, then what happens is you lose the ability to do your life cycle costing. So I'll give you an example of that asset. Say it was a breaker being switched out. You can't just take the 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 breaker that was in your CMMS and just change the serial number and change the manufacturer to what the new one is. You actually have to take that asset that was in that one place, you have to move it to wherever it's being moved to. You have to put a new asset into its place. And if you do that properly, then all of the information on the asset follows it. And that enables asset management. So it's really important that you keep track of this with a proper management of change process and that you do all of these changes correctly within the system. And otherwise you can lose track of your system within less than a year. The other, and you also have to look at all of the different systems that are impacted by these things too, right? So if you do change an asset, you have to look at what are the safety impacts, what are the environmental impacts, dam safety, operations, maintenance, inventory, finance, asset software systems. Every one of these is impacted by the change. So you have to have in your management of change process, you have to make sure that each of these groups are consulted appropriately for when the change occurs. And some of them may actually have to require formal sign-offs. So finally, this is something that most people don't consider to be part of asset management, but it definitely is the contracting out decision. So as part of when you're developing your asset management plans per asset class, one of the decisions you have to make is who's doing the work, right? So, and because you can imagine now, if you decide it's going to be contracted, now you have to say, well, what are the competency requirements for that contractor? What do they have to do? They have to be aware of your asset management objectives and processes, and they have to be aware of the information requirements to feed the required planning and performance processes. And what I didn't talk about here, well, now once you made the decision for contracting, now does it affect your inventory? Like, what are you doing for spare parts? What are you doing for tools? What are you doing for training of contractors? All of these other decisions. That's why it's part of asset management, because if you have the task being done by an internal person, you have to address all these questions for the internal people. If you have it being done by an external person, well, now you have to address all the questions for that contractor. And I know one of the gains they talk about for contracting out is that, well, now I don't have to worry about my contractor proficiency, right? I count on the contractor having trained people. Maybe fair, maybe not. That is one of the reasons why you do stuff like elevators, trains. It's water systems quite often contracted out. It's just too expensive for you to maintain that competency internally. But again, it's an asset management decision because now you've decided that the investment, saving the investment on training, is worth the additional money for contracting it out. So it's part of that asset management plan for that asset class, and therefore it's an asset management decision. And Chris, I think that officially takes us to a summary, and then I think we can head out for coffee.
Sure.
So for everybody, life cycle management. Actually, I've got a knowledge check too, I think. Yeah, I do. Lifecycle management. Asset management provides actions, processes, and data requirements for all aspects of the asset. The asset life cycle is planning, acquisition, operations, maintenance, and decommissioning. Management of change processes must be in place to ensure data accuracy for asset management and all other processes such as safety, dam safety, environmental licensing, all that other good stuff. And the outsourcing decision is part of asset management, includes the actions, processes, and data requirements. Which leads to a knowledge check. Asset management is based upon managing assets to obtain the required value over their life cycle. The components of an asset life cycle are, and I'm getting too dry to read them all this time. So let's see if Melissa wins again. Oh, Richard won. Yes, it is planning, acquisition, operations, maintenance, and decommissioning. I couldn't put in all of the above in this one. Good. So should we go for coffee?
Yeah. So let's take a break. We'll come back at 3:30 p.m. Eastern. Yeah.
Perfect. Okay.
All right. Thanks.
Excellent. Thank you.